This is a continuation of the previous tutorial. Here we're gonna implement a gravity effect so that the player can fall off the bridge if he runs past the segments. So let's delve right in. This should be a short tutorial. Open up the player controller script in Visual Studio. First, let's create a float that's gonna act as the free fall gravitational constant, just like in real life. And we'll name it G value and set it equal to 10 units per second, close to the real 9.8 meters per second value. Now let's create a function that's going to be in charge of implementing the player's logic and appropriately name it player logic. And it's of type void, which means that it doesn't return anything, it just executes the code that's inside it whenever it's called in the script. I want to emphasize that this function is our own creation, unlike the start and update functions, which are part of Unity by default. We've just created this function to help us develop this game and make our code neater. Let's cut and paste the content of the update function into the newly created player logic function. And now we'll simply invoke the player logic function from inside the update function by typing its name followed by a pair of parentheses and a semicolon, of course. So now when Unity runs our game and executes the code that's in this script, when it comes to this line, it's gonna immediately jump into the body of the player logic function and runs the code that's inside it, and then jump back to the update function and executes the rest of the code if there is any. You can already see that our code looks more modular and reusable. We have one function in charge of one thing, and it can be used and reused by simply copying and pasting its name in whatever line in the script, and we'll certainly do that in future tutorials. Now let's step into the body of the player logic function and write a simple if statement that's gonna check whether our player is touching the ground or not. Type F, and then open a pair of parentheses, and what goes inside the parentheses is the condition that we want this if statement to check. Let's type small c, character controller, and we'll use the isGrounded method, and we are aware of its existence and how it's used thanks to the Unity manual. This method returns true if the player is touching the ground and false otherwise. So, if it's true that the player is touching the ground, then open a pair of curly brackets, and we can see that Visual Studio automatically pairs the two brackets. Then, player vector, .y, so now we have accessed the vertical component of our player vector, equals, and let's give it a negative value, say minus 0.2. and terminate the line with a semicolon. So this statement basically reads, if the player is touching the ground, they push him further against the ground. This is so that we can be really sure that our player is really pressed against the ground. Now type else. Else what? Well, if he's not touching the ground, then he must be up in the air. So type player vector .y equals the current vertical position of the player from when he's up in the air, which is player vector .y, minus, so let's subtract gradually from the player's altitude by the free fall gravitational constant value. So open a pair of parentheses, G value times time delta time. Terminate the line with a semicolon. We put the parentheses around these two terms to indicate that they are one quantity, and you don't need to put the curly brackets for the else condition. So now if we read this if statement from the beginning, it says, if the player is touching the ground, then further press him onto the ground. Else he must be up in the air, in which case pull him gradually to the ground 10 units per second, which is the speed we have specified for the G value. We call this entire block of code a single if statement. Okay, this takes care of the gravity behavior in our game, but before we check our newly scripted behavior in the Unity editor, let's add one little line in the beginning of the update function to make our player pick up speed as he runs further and further in the game. So type player speed plus equals, and I'll explain what this plus equals symbol means in a second. Then type 0.005 times time delta time, and the line with the semicolon. So this plus equals symbol is a shorthand notation for, and let's add a comment, player speed equals player speed plus 0.005 times time delta time. So instead of us writing it out like this, we could reduce it to this expression. This means that we could also write this line as player vector .y minus equal G value times time delta time. Also, this part of the line means add half a unit of speed to the player's run speed every second. And we haven't factored in this updated speed of our player in our player vector variable. We're actually gonna do that in the next tutorial because it's gonna need some other piece of code that we have not yet written. But right now we'll leave it as is. Finally, let's go up here and declare a float with the name player start speed and set it equal to 10 units per second. Also, let's remove this initialization from the player speed variable and initialize it in the start function instead. So right here before the character control line, type player speed equals player start speed and the line with the semicolon. So now we have one variable for the player's start speed and another variable for when his speed gets incremented. And this will come in handy when we write the death event for the player later in the course. Let's save our changes to the script by hitting Ctrl S or Command S if you're using a Mac. Now let's go back to the Unity editor and make some changes in our scene to test our script. First, let's create a plane that's gonna be in place of the bridge segments until we figure out how to spawn bridge segments in a future tutorial. Go to Game Object, 3D Object, Plane. Double click on the player game object to bring the scene view closer. Reset the transform values of the plane. Elevate it with the move tool until it's right under the player's feet. Now this looks like an appropriate track to test our player's newly programmed behavior, i.e. getting pulled down by gravity. Save the changes by hitting Ctrl S or Command S. Let's hit play and see what happens when the player runs off the track. It looks like we have succeeded in implementing the gravity effect in our game. That wasn't too difficult, huh? Now comes the end of this tutorial. In the next tutorial, we're gonna make our player turn left and right when certain keys are pressed from the keyboard. Thank you.